question, but typically that is, what we need to do for that equation. All right, for the next question is kind of just like that basic understanding of a radian and a degree, as well as the equation S equals R times theta. And the really only kind of topic I just wanted to kind of cover with this is, one thing is we understand that halfway around circle is 180 degrees. And we know all the way around a circle, like when you rotate halfway around a circle, like that's a straight line. We recognize that to be 180 degrees of rotation. And when we rotate all the way around a circle, basically going a full revolution, that's 360 degrees, right? So from our geometry class, like we take the straight angle is 180 and then the full circle is 360. And then so when I talk about radians, basically the way that I explain radians to my students is I said, well, radians is basically kind of using the idea of our radius. Let's just use blue here and saying, all right, here is R. And what if we took R and wrapped it around the circle? Yeah. So if we took R and wrapped it around the circle, what we would have is, like if we rotated it like this R wrapped around the circle, from here to here would be the measurement of 1 radian. From there to there would be the measurement of 2 radians. And then from here to here, that rotation would be a measurement of 3 radians. So if we were to rotate all the way halfway around a circle, we could say it's going to be 3 plus a little sliver, which ends up giving us pi. Whereas all the way around the circle is going to give us 2 pi. Okay, so that's basically what, pi is. It's the number of radiuses that it takes to wrap around the circle. Now, again, that kind of comes into our next play is, well, what about when the, radius is kind of like different? So when we look at, like, let's pretend the radius here is 1, all right? And so the radius is 1 here, and let's just do 1 radian. So again, what S represents is this actual distance. So remember, an angle is representing a rotation, is a measurement of the rotation. So we're actually measuring these arrows of rotation. Whereas S represents here this actual distance that you would have to travel from here to here along that circle. So if my radius is 1 and my radian, the degree of rotation is 1, then you can see S is going to be R times, theta. Like, so S equals 1 times 1. And what the important thing that happens here is, what about when I get to, like a radius of 2? And my circles are getting really bad. But again, what you can see here is now my radius is from here is 2, but the angle does not change, right? The measurement from here to here is still 1. So what happens is, how does the S change then? Like, how does that measurement of S change? Well, all happens with S is now equal to a radius of 2 times 1. So S is now equal to twice that size. So when you're doing the S equals R times theta, that central angle, the main important thing is to make sure you understand that R needs to represent as a radian. So